Okay, so these are the scores on the test. This is the overall combined score. You're making some progress, but I know that there's some people that could definitely be doing a little bit better. So, just try and make a little bit of progress every day. And I really am confident that everyone in this class is definitely capable of getting a 5. So if you're not quite there yet, keep the faith, keep trying, and you'll get there. We'll have plenty of time to review, but don't rely too much on that. Really try and bust it out this last quarter. I mean, really, in the fourth quarter, we're hardly doing anything. So this is like the last quarter of calculus. Just really work hard, and you'll be glad you did. All right. So what's that?
Isn't this like our last year?
2 more. We have Unit 7 and Unit 8. Unit 7 is only 6 days of instruction. That's it. And then we'll do, like progress checks and tests and all that stuff. So it'll be a little bit longer. But then Unit 8 is only, I think, 8 days of instruction. There's really hardly anything left. So we should really start trying to wrap it up and really try and get a handle on things in terms of like concepts. Make sure you understand what's going on. And then you'll see as we do review and stuff, all the problems will start to make a lot more sense. And it just there's only a few types of problems that you're likely to see, especially on free response. There's maybe 7 or 8 different types of problems. And if you just know how to do those 7 or 8 types of problems, you could do really, really well on the free response. So, all right, so I'll answer any questions you have on any part of this test. Just specify whether it's the non-calculator part, which is the first part, or the calculator part. Yeah, John.
Can you do the free response question on the non-calculator part?
Sure. Free response, there's 2 free response questions.
The 12.
Okay. Okay, so this is number 12 on the non-calculator part. Okay? So there's a graph that's given, that's just a piecewise linear function. So we have the point -4, -3, and then the point -1, -2. And then the point 1, 2. And the point 3, -2. Okay, so they tell you this is the graph of f. Okay, and it says for part A, let g of x be given by the integral from -4 to x f of t. dc. So before I go any further, I'm going to make this connection. G prime of x is f of x, right? That's FTC part 2. This graph that they gave us is G prime. Okay? So for part A, they want you to find G of 1 or -1. So G of -1 is just the integral from -4 to -1 of this graph. So this is a question where they're asking you to look at areas. So from -4 to -1 would be like this trapezoid area right there. So you can just count squares. The rectangular part, don't focus too much on using a formula and stuff like that. This rectangular part, you just count squares, is 6. And this triangular part right here, if you just count squares, is 1.5. So it's just 7.5. That's all there is to it. And it's negative because it's a signed area, right? It's below the x-axis, so it's -7.5. G prime of -1, this is the graph of G prime of x. So G prime of -1 is just -2. It's just the y value on this piecewise linear function. It's -2. That makes sense so far? G double prime of -1 does not exist. They don't ask you to explain why. but this is the graph of G prime. So G double prime would be the derivative of this graph, and there's a corner there. That's why its derivative does not exist. Okay?
So how many points did you get?
This question was worth 3 points, 1 point for each of the answers. Okay? Part B, this says, for G defined in part A, find the x-coordinate of each point of inflection of the graph of G on the open interval from -4 to 3. So points of inflection, remember, 2 things have to be true for there to be a point of inflection. The second derivative has to change sign, and the function has to be differentiable, okay? So we know the function is differentiable. We know that G is differentiable because this is G prime, and it's defined everywhere on that interval. So that part's taken care of. We just have to find points, or a point or points, at which G double prime changes sign. Okay, so if I take G double prime, this is equal to F prime, right? If G double prime equals F prime, that's the derivative of this graph, the potential points where G double prime might change signs would be points at which G double prime is 0 or undefined, right? So you have to make a little second derivative chart. Make a second derivative chart, looks like this, -4 to 3. And then you can see it's undefined at -1 and at +1. Right? So I have -1 and +1. And if I make a chart, G double prime is positive, right? It's the slope of this line, and then it's positive again, and then it's negative. I'm looking at the slope of this curve for G double prime. So it goes positive, positive, negative. Concave up, concave up, concave down. So the point of inflection is only at 1. So all you have to write here for an explanation is you would say G has an inflection point at x equals 1 since G double prime changes sign at x equals 1, and G of x is differentiable. That's it. Okay, that's the explanation they're looking for. This question was worth 2 points. 1 point for getting the correct point, x equals 1, and 1 point for your explanation of why. A sign chart's not good enough as an explanation. They want words. Okay? Part C. This question says, let's define a different function, h of x, to be the integral from x to 3 of f of t dt. Again, before I even read what they're asking me to do, I'm going to make the connection h prime of x is negative f of x. Does everybody see why it's negative? FTC part 2 says if you integrate from a to x and take its derivative, you get f of x. So if you switch limits of integration, it changes the sign of the definite integral. So this is going to be negative f of x. So if I look at my graph up here, this is what h prime, or sorry, this is what, h prime looks like. This is h prime of x. It's the negative of f of x. Does that make sense? Okay, that's an important connection. Okay, so then the question is asking, find values for which h of x equals 0. Okay, so h of x equals 0. H of x is an area. It's a signed area under the graph of f of t, right? So you just need to know, well, if I go to 3, under which circumstances would I get 0? Where do the areas actually cancel out? Well, if you look at your graph, this area right here is 1.5. This area right here is 1.5. This area right here is 1.5, and this area is 1.5. So just integrating from 1 to 3 would give me 0, right? Because the 1.5 cancels with the negative 1.5. And integrating from -1 would give me 0 because you'd have -1.5 plus 1.5 plus 1.5 minus 1.5. So there's 2 points that lots of people came up with. H of x equals 0 if x equals -1 or +1. The one that people forgot is 3 would also work, right? This is, they want you to look at the closed interval from -4 to 3. And if you integrate from 3 to 3, you also get 0, right? So that's one that people tended to forget in this case, but that definitely works, right? This question was worth 2 points, and the grading rubric said -1 for each missing value. So if you didn't have this, then you only got 1 out of the 2 points, okay? That make sense? And then part D,
Wait, so if you got one of those, but only got one, would have gotten no points?
yeah. Yeah, if you just got at x equals -1, no points. Question D, it says for h defined like that, it says find intervals on which h is decreasing. Well, h of x is decreasing if h prime of x is negative, right? In other words, if negative f of x is negative. Well, negative f of x, or in other words, if f of x is positive, right? So you just want to look at this graph and just see when this graph is above the x-axis. Because when f of x is above the x-axis, negative f of x is below the x-axis, which means that h is decreasing. So it's going to be from 0 to 2. That's it. So this is on the interval from 0 to 2. That's it. That's all you have to do. I stated a reason. The reason is because h prime is negative, but h prime is equal to negative f of x. So if negative f of x is negative, then that means f of x is positive. That's it. This would be a full credit answer. This was worth 2 points as well. 1 point for getting the correct interval and 1 point for explaining. So if you got the wrong interval, like you said, if you said h prime is f of x, and then you said, well, so f of x is negative from -4 to 0, and from 3 to 4.
2 to 3.
Did I mess up? Oh yeah, no, from 2 to 3. If you said that, and you correctly had because it's negative, because h prime is negative, you get 1 point for having the correct explanation why, but not the point for the correct interval. Yeah.
So, quick question: would that ever take off points if you did interval notation incorrectly? Because
That's a great question.
Because from 2 to 3, I did brackets on both sides, but I don't think 2 would be included. Like, it would just be
Yeah, I agree. I don't think they would, but I can't guarantee that. I do know that I spoke to an AP reader at a conference one time, and he said that they accept like any kind of they would accept this in words. They would accept like totally weird notation as long as it's clear that you know that it's numbers between 0 and 2, then you're good. Now, in terms of including endpoints, it definitely shouldn't be included, right? Because like at 2, the derivative of h is not negative, it's 0, right? So it's not decreasing at that point. But when you think about an interval of numbers, and you're saying it's decreasing on this interval, including the endpoint or not including the endpoint doesn't really have that much effect on your answer. You know what I mean? Because you can't talk about a function decreasing. Well, I guess you can at a point. But yeah, I don't know. I don't know if they would take points off if you included an endpoint or not. That's a good question. Better safe than sorry. It definitely shouldn't be there. So if they did take off a point, they kind of, should maybe. Yeah. Sure. Number 3 on the no calculator part was a little bit tricky. You have the integral of sine x minus cosine x squared dx. Okay, so you could FOIL this out, right? This is really sine squared x minus 2 sine x cosine x plus cosine squared x. Does everyone agree? That's what you get when you FOIL it out. And sine squared x plus cosine squared x, what's that?
1.
That's 1. So this is really the integral of 1 x minus the integral of 2 sine x cosine x dx. Everybody okay so far? So this is x plus c minus, now I can use u substitution to do this part. This is a tricky one. So you could say u is sine x, du is cosine x dx, dx is du over cosine x. So this ends up being 2 integral u cosine x du over cosine x. So you get 2 u squared over 2 plus c. So this is x minus sine squared x plus c. Does that make sense?
Yeah.
Another thing you can always do if you can't figure out how to do a problem, an integral problem, is just differentiate. If you differentiated part c, you get the correct answer. But again, you'd have to recognize that it has to be FOILed out in order to get that answer. So this is a little challenging one.
Yeah, otherwise you have to know the rate relationship or whatever.
Oh, you definitely have to know Pythagorean identities. That's for sure. Yeah. Well, maybe now. That's the thing about it. All right, what else? Oh, sorry.
11 on the calculator.
On the calculator part?
No calculator.
No calculator part. There was a couple different ways to do this. I was pleasantly surprised. People came up with a different way to do it than I did it. So we have the integral of x dx over x minus 2. So the way I was intending for people to do it is to use u substitution, and it's kind of hard to do it that way, but that's why it was worth 3 points. Here's the way that I was thinking. I was thinking u is x minus 2, so then du is dx. Now the problem is when you make that substitution, you get the integral of x du over u. There's still that x there. So I explained this briefly in class, and I just wanted to see who could figure this out on the fly. But the way that you can handle this situation, if things don't cancel and you can't think of anything else for u to be, is sometimes you can take the expression you have for u and solve it for x. Oh, I messed up the original problem. Thanks. So this is now going to be minus. Okay, so far? Now you can substitute that in. So this is going to be u minus 2 over u du, which you can break this up into 2 fractions. You can't break this up into 2 fractions if the denominator is 2 terms, but you can break this up. This ends up being 1 minus 2 over u. So the integral would be u minus 2 ln u plus c. So it's x plus 2.
That'd be 1 minus 2 on u.
Or the integral of 1 is u.
Yeah, you're right.
Okay. So this is minus 2 ln absolute value x plus 2 plus c. So that's kind of what I was thinking when I wrote this problem, is that was what I was trying to test you on. But people did long division, which works great and it's easier. So I'm glad that people came up with that. So if you take x divided by x minus 2, it works great. This is just going to be 1. If you multiply it out, you get x minus 2. Positive. Oh yeah, plus again. Why did I do that again? And then subtract, so you get negative 2. So the remainder is negative 2. So this is really minus 2 over x plus 2. So the original fraction, x over x plus 2, is really this fraction. So if you take the integral of 1 minus 2 over x plus 2, you get x minus 2 ln x plus 2. That's the shortcut u substitution, plus c. Now, why did I get a different answer here than I did here?
Yeah, so.
Because they're derivative.
Yeah, it doesn't matter. The derivatives are the same. I could lump this 2 in with the plus c. It wouldn't matter. I get the exact same function, right? This is just a vertical translation of this. So it doesn't really matter. What happens if you forget the plus c in a free response question?
You lose a point.
You lose a point. That's such a waste. Don't forget the c, okay? Because that was worth as much as a multiple choice question. That plus c was worth as much as a multiple choice question. So don't take that risk. Don't forget it. All right, what else?
You ate on this video.
Sure. Number 8. This was a little bit like one that we did the day before on progress check. The integral from 0 to 2, 3x squared f of x cubed dx. This is u substitution. U is x cubed. So du is 3x squared dx. Dx is du over 3x squared. So if you make that substitution, this is the integral of 3x squared f of u times du over 3x squared. Now I just need to change the limits of integration. If I change the limits of integration, if this is u, then if x is 0, u is also 0. If x is 2, like in the original integral, then u would be 8. So this real problem is really just the integral from 0 to 8 f of u, which they actually tell us what that is. It's k. The answer is k. That's it.
Okay.
At least you didn't say f u. All right, what else?
You need 5 on that, on this one?
Sure. Number 5, the integral from 0 to pi of cosine 4 x plus pi sine x plus pi dx. So this is a really similar problem. It's just u substitution, and you got to change the limits of integration. So what do you think u should be in this case? Cosine x plus pi. And if you just think about that, and it'll definitely work. If you just think about that, that automatically rules out a and b. It can't be a and b because they still have cosine in it, right? So u is cosine x plus pi. Du is negative sine x plus pi. Dx, so dx is du over negative sine x plus pi. So if I do that substitution, this is u to the 4th, not cosine u, it's u to the 4th, sine x plus pi times du over negative sine x plus pi. So these cancel, and I have negative integral u to the 4th. Now let me change the limits of integration. If u using this. If x is 0, then u would be cosine of pi, is -1. And if x equals pi, then u would be cosine of 2 pi, which is +1. So this is the integral from -1 to +1. But since this is negative, I could get rid of that negative. How? By switching these. So this is really the integral from 1 to -1 of u to the 4th du. Now, some of you had the wrong answer, because originally I had the wrong answer on my answer key. Okay, I had d was the correct answer because I forgot to switch the limits of integration. So if you put d the first time around, and then I went through and checked them, I did not take those points off the second time. But if you correctly wrote c the first time and I marked it wrong, then obviously I give you credit for that. So don't fool yourself in your brain. If you did not get that question right, if you selected D, and you did not get that question right, but I gave you credit for it. So just keep that in mind. I don't want you to think that you got it right, because you actually didn't.
I think the B
Correct answer was C.
Get credit too.
Definitely not. I think there were 3 people that put D the first time and ended up getting credit for the question even though it was wrong. So just be careful. All right, what else? Yeah, John? 7. The integral from 0 to 1
Yeah.
of e to the negative x plus 1 of e to the x. E to the negative x. Okay, so if the denominator is just a single term, then you can split it up into 2 fractions. That's the easiest way to do this problem. Okay, so that's what I'm going to do. This is really just the integral from 0 to 1 of 1 plus e to the x. Right? Because this fraction is just 1. This fraction is 1 over e to the negative x, but to make that exponent positive, I can just flip it like this. So this is just x plus e to the x from 0 to 1. If you plug 1 in, you get 1 plus e. And if you plug 0 in, you get 0 plus 1. So I have 1 plus e minus 1. The answer is e. What else? Yes. On the non-calculator?
Yeah.
Okay.
Yeah, but some actual value doesn't make sense.
Number 9. They're telling you the integral from 1 to 3 of f of x dx is k, and the integral from 1 to 7 of f of x dx. Another thing people forget often besides plus c is dx. Don't forget the dx. I did not take points off, but they definitely are in their rights to take points off. I don't think they would, but it's important to remember, especially if you're ever planning on taking any other calculus class, because once you get up to multiple variables, that d is really, really important. Okay, so just make sure that you keep in mind. All right, so they want to know the integral from 7 to 3, x plus f of x dx. So the first thing I would do is I would split this up. The integral from 7 to 3 of x plus the integral from 7 to 3 of f of x. The x part is easy. This is just x squared over 2 from 7 to 3, which is 9 halves minus 49 halves, which is negative 20, negative 40 halves. So negative 20. This part is the part that requires the properties of definite integrals. And if you just look at what you have the integral from 1 to 3 and the integral from 1 to 7. So I could split this up and say this is really just going to be the integral from 7 to 1 f of x dx plus the integral from 1 to 3 f of x dx. right? Because as long as this upper limit and this lower limit match up, it's sort of like transitive property. So the integral from 7 to 1 is the negative of this, so it's positive 4. And the integral from 1 to 3, they gave it to us, it's just k. So I have negative 20 plus 4 plus k, so it's negative 16 plus k. That's the answer.
This is this whole thing. So simple by negative 4 over 2. I just guessed.
Are you kidding me?
Anything else? On either part? Yeah,
Yeah, can we do part D on the calculator?
sure,
Fair, separate response question.
sure. Okay, so this is a typical like accumulation of change problem for free response. Okay, this was from the 2003 AP test. So it says, at what time t for 0 to 12 is the volume of heating oil in the tank the least? So just in general, if you're trying to find the absolute minimum of something, first derivative test works, right? You want to take its derivative, set it equal to 0, do a little sign chart, identify the candidates, like the relative mins, and then just pick out which one is the absolute minimum, right? So in this case, if you're looking at the volume, you should have figured out in the in part C that the volume at time t is just the initial volume plus the integral from 0 to t of h minus r, excuse me, of h minus r dt, right? H is the rate at which oil is coming into the tank. R is the rate at which oil is leaving the tank. So if you take the definite integral of these rates, then you get the total amount of change in the amount of oil. So this ends up being 125 plus the integral from 0 to t of h of t minus r of t dt. Okay, so this is the quantity that we're trying to find the absolute minimum of. V prime is just h of t minus r of t. That's FTC part 2. You take the derivative of a definite integral, you just get the integrand. That's it, right? This part is just 0 when you differentiate it. So if you set this equal to 0, that occurs when h of t equals r of t. And if you graph these on your calculator, you get 2 points of intersection. You get t equals 4.790 and 11.318. Does anybody need me to do that, or you're cool how to figure that out? Okay, now if you make a little chart, the chart looks like this. This is h, or v prime rather. 0, 12, this is 4.790, 11.318, and the chart looks like this: positive, negative, positive. So there's 2 potential relative mins. There's a relative min at x equals 0 and at x equals 11.318. You now need to test. Determine what the volume is at this point, determine what the volume is at this point, and then just compare them. So if this is just given to you, it's 125. And if you apply 11.318 to this formula right here on your calculator, you get V of 11.318 is 120.738. So that's the absolute min. Now, this question was worth 3 points. The first point you get if you correctly set h equal to r and get these answers. That's 1 point. The second point was for getting the correct answer, 11.318. The third point is your analysis, which includes testing the volume at 0 against the volume at 120. So if you did all this work and said, oh, definitely that's the minimum, it's definitely not clear that that's the minimum, right? This might be the minimum. So you have to, that's important that you test it at 0. Even though that's a given thing, you have to find this volume and make sure that it's smaller than that, just to say that this is the absolute minimum. Okay, so if you did everything except the comparison between 0 and 11.318, you get 2 out of those 3 points. Anything else? Okay, like I said, I'm really happy with progress so far. Some people could be doing a little bit better, so let's just try and pick it up. I have one question here, problem of the day.
I have something less. He said question singular.
I gotta make it. I don't know how to get rid of this. How do I get rid of this stuff? Does anybody know? No?
What if you hit that button in the top right, or something?
Oh, thanks. All right. So this is a non-calculator question. If fx is the solution of this differential equation with the initial condition f of 0 equals 2, which of the following is true? It's D. When I first saw this question, I'm like, oh, I have to integrate and try and find the solution, the particular solution to this differential equation with that initial condition. That's a waste of time. You don't actually have to do that. This is just FTC part 2 directly. It's right here. Okay? Now, I know it's this and not this, because even though this is true, like if I differentiate f prime here, I definitely get e to the x squared, but it doesn't have this initial condition met. If you substitute in 0 here, I mean, I don't know what that is, but it's definitely not going to end up being 2. It's going to end up being something irrational because it's e to some power. Okay? But here, if you plug 0 in, this whole part right here becomes 0 and you get 2. And then when you differentiate it, you just get 0 plus this thing evaluated at x. That makes sense? So this is a question that potentially you could waste a lot of time on, when in reality, it's a 30-second question. Okay? Any questions? So tomorrow we'll start with unit 7.
Yeah, exactly. I forgot to evaluate it. I forgot that 0 was an option. So let me put it in my own. But then